Thank you for attending this presentation. We're going to talk about how to secure AI running on containers. And the key thing is, AI has, in terms of running AI, containers and Kubernetes has become the de facto for running these workloads. And if we can see, there's a recent stat from the 2024 data on Kubernetes study, and we're seeing an increased growth in AI and ML. And that's because of the scalability that Kubernetes brings to the table. There's also a huge ecosystem play. There's tools out there like Kubeflow, which can be used to run AI and ML pipelines. And we've seen an exponential spike. For example, NVIDIA GPUs running on EKS Kubernetes, for example. However, there's been a recent wave of attacks that are happening. Prompt injection attacks. There was a recent one, for example, on NVIDIA GPU toolkit, where a malicious GPU was able to load a shared library that exposed AI workloads and gave full host compromise. And even your AI supply chain is compromised. You never know what's going into the packages, whether it's AI libraries. And so you have to have full code to cloud protection across your AI supply chain. And so when we look at risk-minded AI container security, it's your container security, but more evolved. One specific example is we're working with a large video game company today, and they're trying to run their GPUs, they're trying to run AI workloads. Those GPUs are taking a lot of memory, a lot of compute. So they need to be able to do it they're scanning in a way which is optimized. Similarly, you have to have signature-free detection. You have to be able to catch your AI supply chain attacks, and that requires signature-free zero-day malware detection. And then making sure you can have blast radius aware security, making sure that whatever your training data is in the cloud is not compromised based on your AI security and containers and LLMs running on it. And that's where we're announcing Qualys AI workload protection for containers. The idea is we have a full blast radius attack path and integrated visibility into any AI model running on your Kubernetes clusters. You have the ability with one click to scan your LLMs instantly and discover all the software, all the packages running on Kubernetes GPUs. We correlate those risks with the OWASP top 10 for LLM. And so you have a detailed idea on not just the attack path, but what kind of AI attack is it? Is it supply chain related, prompt injection, all those types of attacks? With the on-demand LLM scanning as well, we have 100+ detections. And we've evolved our vulnerability library in Qualys to include AI-based detections for DeepSeek and other jailbreak models. And it's a full supply chain protection from cloud to cloud. So the zero-day malware is actually integrated into our registry scanning as well. So you can make sure you can catch that malware before it reaches your production environments. And when we talk about operationalizing your risk operations center for containers, it really starts with being able to have a full unified asset inventory, correlating the business context with runtime context, and then being able to execute remediation and compliance. And at Qualys, we provide not just the attack path and the insights, but the code-to-cloud vulnerability management, automated ticketing, eBPF runtime protection and detection. And the eBPF piece is really important. I'm sure you all have been reading a lot about runtime security. The key with AI is there's less signatures available. So you need to be able to actually look at process events, file events, network events in real time to be able to catch the new vulnerabilities, catch the new threats that are actually taking place in AI workloads. And then you want to be able to continuously audit. There's actually a new requirement in PCI, for example, for cloud and containers, where before that was an exception. Now you actually have to have cloud and container visibility in real time. So the first part is about noise-free container risk prioritization. You're running a lot of AI workloads, hundreds of thousands potentially. How do you make sure you get a single toxic combination of risk? And so what we do at Qualys is we actually correlate real-time telemetry, for example, malware, vulnerabilities, exposure context. We combine it with the business context, and we calculate toxic combinations of risk. And when you look at the overall attack path, right, you can see here, for example, your pod's exposed to the internet, your AI model running, but then making sure if it has a blast radius to, for example, the training data, you're able to see that as well. Similarly, we want to give the visibility into the code to cloud traceability. For example, if a new vulnerability or new AI package was introduced, how do you trace back to the development team? So we're integrating with the likes of Checkmarx, Sneak, Veracode to be able to give this visibility if you're using any SAST or SCA tooling. And today we work with one of the largest financial banks. You may be using their credit cards here today. They scan over 2 million containers daily. But they're able to burn down their risk systematically because they start with understanding what are the risky exposures, filtering out what is actually business critical. We have the ability to dynamically tag assets or containers, which are ephemeral, so you can automatically have that business context from day one, but then really remediating with the attack path insight. We recently launched our ServiceNow CVR integration. If you're using VR for host, it's the same concept, CVR for containers, where we can auto-close tickets for new container vulnerabilities that are introduced in your environment, create custom exception rules, remediation paths, and more. And this is my favorite, the eBPF and AI-powered detection and response, where we're able to detect drift, anomalies across process, network, and file events. But even more than that, it's looking deeply in the image. We use a packet-based technique without signatures to detect malware and correlate that with your attack path, and then give you the remediation, the ability to do process quarantining, file access locking, and AI-powered incident response with Mistral AI. So your threats that are coming in, you might have a lot of alerts. How do you summarize that? How do you give your incident response teams the ability to understand what remediation steps I need to take next? And finally, the Kubernetes security posture management, the ability to continuously audit your clusters for CIS, PCI, NIST, block non-compliant deployments with the admission controller, and have integrated remediation playbooks with low-code, no-code workflows. And this is one on FIM. We actually have a lot of customers who are using our host FIM today. In Qualys, we have now unified that FIM across hosts, network perimeter scans, and containers as well. And the key thing is if you can prioritize with Kubernetes context across large environments and satisfy your PCI audit needs for PCI 4.0 in one single platform with Qualys FIM. So now I am going to go to the slide, or to the demo. So when we start, we have the ability to actually drill down into what are your images with critical vulnerabilities, the ones with drift. What is your overall true risk across my entire environment? What are my posture controls, container breakdowns? But this one is key. You want to be able to systematically burn down your risk. So we have this martini glass that actually tells you, out of all the total findings, what are the ones that have attack paths for your AI workloads? You can then filter down to what are the AI workloads running in your environment. And these are these toxic combinations. For example, here we have an internet-exposed AI workload with an exploitable vulnerability and threat findings and storage access. This is possible across on-prem and cloud Kubernetes clusters. And when we go inside, we'll take a look at what that actual attack path looks like. So looking at the attack path, as you saw before, you see the full blast radius, the exposure. We see here that this container has a blast radius to the training data. It has this code to cloud visibility to see where the new vulnerabilities are coming from, and actual runtime threat findings from eBPF. So we see here, in this case, the attacker auto-mounted a service account token, did a container escape to get from the container into the actual GPU, and deployed a sidecar, and then actually did a data exfiltration attack into the training data. So now, yep, I will skip through. So now you could also see the misconfigurations, the vulnerabilities, the threat findings. We also give an AI summary of where the vulnerability was introduced. It turns out in this case, a new NPM library was introduced, and that caused this attack. You can go into the AI model. We're correlating this with OWASP top 10. So in this case, the true risk score is actually higher for this AI LLM model. You have the ability to do the LLM scanning right from the attack path. You can see that this LLM is correlated with model theft. I was talking about the data exfiltration and supply chain vulnerabilities. And this looks like this LLM was deployed 4 days ago. Now, when we go into the container, you're able to go to the threat findings. And the key thing is we have this concept called QLP. QLP is a way to stably identify your threats across large environments or vulnerabilities. You could have millions of containers, but how do you group across pod, namespace cluster, and have your risk quantified across a single measure? So here, for example, we have a container QLP, and we can see the different findings across the different Azure subscriptions. We see the different threat findings with that QLP that I was showing in the attack path. And now you have the ability to instantly remediate. So we can do some different remediation actions. First, we want to do a process quarantine of the process that was actually doing the data exfiltration. But next, you might want to do some customized remediation, maybe rotate the secrets that were used in your Azure subscription. So this is our Qflow. It's a low-code, no-code, drag-and-drop workflows. You can do any automation with this. You can close off your security groups. You can do ticketing. You can even call into different third party. Here, what we're doing is we're going to list the service accounts in the Azure subscription. We're going to rotate the secrets, and with one click, we have this ability to have a remediation in the cloud as well. And the key thing is we have 300 plus playbooks out of the box today, and you have the ability to customize. Now it's about staying compliant. So we saw this container is actually, it's a privileged container, and it turns out this is actually valid going against CIS benchmarks. So when we look at CIS, they actually say to minimize the admission of privileged containers. And so we can see here the same QLP for that stable identifier. But when we go into the actual evidence, we can see the actual pod spec. In Kubernetes, there's always a challenge, especially if you're not a coder, of what was that YAML that actually led to this misconfiguration in the first place. And then finally, we give you an AI-assisted recommendation and remediation to actually, for example, scope the allow list for the privileged containers and create an admission controller policy. Admission controllers is basically your thing that catches pre-deployment. If it sees privileged containers, if it sees some CIS validations, it can actually block before it's deployed in runtime. And finally, code to cloud. If you're using SAST or SCA tooling like Checkmarks, Sneak, Veracode, the key thing is you have all this data about your code repositories and your code vulnerabilities. You want to actually correlate that with the vulnerabilities that you see in runtime. And the reason is you want to decrease your mean time to remediation by knowing if there's a new vulnerability, where was it introduced from? So it turns out here that we can see that it was introduced via this commit. And then we're actually mapping that to the image layers. Did it come from a base layer, which is owned by a SecOps team, or an application layer, which is owned by a development team? You can see the associated containers for this image. And then we can go into the image layers again to see the actual findings associated. For example, on this Python library, NPM model, which actually was exfiltrated by the attacker. And we can see here that you can see the actual Git commit. You can see the Docker file where this library was introduced. And you can actually see the SAST findings from your different third party. And then instantly remediate in real time. So here, it's about quantifying your risk, measuring your risk, systematically burning it down. So we're showing you the risk decrease, for example, from 861 to 572, if you're able to execute this pull request. So if you're interested in learning more, we're happy to give you a demo on container security. We also do cloud security as well. We have support for LLMs, Hugging Face, Bedrock, running in on-prem and cloud environments. And you can get your free custom true risk report today. We also have something called QScanner, which basically you can instantly scan for images right on your laptops or machines and see how to bring true risk to your development teams. Thank you so much.